Okay, here we go with a question about the direction of the velocity of particles in a wave. It's quite a nice question, sort of conceptually about the wave model. As ever, please take a second to try it, and then when you've had a go or you give up, press play to see my attempt at explaining this one. Okay, so like I say, I think this is a little bit different to previous questions that I've seen. We've got a graph showing the displacement of a wave. So we've got this nice wave profile here with position x. So really we're traveling along the wave. We're imagining that we're somehow pausing time and we're just seeing the profile. Now we're told that the wave travels towards positive x, okay? And so basically what it means is it's moving to the right. We want to know at which point along the wave it has maximum positive velocity. Now what this means is these points A, B, C, and D, when are they traveling in the positive displacement direction? Now the way that I've thought about this is to think about, I'm defining velocity. I'm going to say that velocity is the change in the displacement over time. Okay, now the tricky bit here comes relating to the graph, and I'm going to use a little bit of math here. I'm going to use this where I'm going to say, you know what, delta y over delta t, that's the velocity. Okay, I'm going to say that delta y over delta t, I'm going to introduce a factor of delta x on both the top and the bottom. So that's going to be delta y over delta x times delta x over delta t. Now this delta x over delta t is constant, that's just the speed of the wave itself. And so we're really interested in this delta y over delta x. If this is 0, then the velocity is 0. Okay, if this is non-zero, then the velocity itself will be non-zero. Let's take a look at points A and C. Hopefully you can notice that these are turning points. Okay, which means the gradient at each point is 0. Okay, so if I take this expression here, velocity of point A, it's going to be delta y over delta xa times delta xa over delta t. It's going to be equal to 0. Why? Well, look at this leading term here. Delta y over delta x, i.e. the gradient of this graph, is equal to 0. 0 times anything is going to be equal to 0. Similarly, for C, it's exactly the same argument. That we've got the gradient here at the front, gradient is 0, therefore speed is 0. So I can get rid of these 2 points, A and C. Now the question next is, which one of these ones, B or D, has positive velocity? For this, we need to think about the gradient itself. Okay, if we are moving this way, okay, our wave moves in the positive direction. And then you can see here that this point here, A, is going to move to the right. Now what that means, in order for this to occur, B must lift up, which means it has a positive velocity. D, on the other hand, is going to move down towards a trough, and what that therefore means is that, whoops, skip to the next one, our answer here is B, because the point at B is moving upwards, i.e. positive, so that we can have a crest at a later time point, T.